Bismillah ar-Rahman ar-Rahim. So this is fundamental problem 7, chapter 7, problem number 9. It asks us to determine the shear and moment as a function of x and then draw the shear and moment diagram. So this is what are we given in here. The first thing we need to identify is, we're going to start always from the left hand side, from the 0 meter all the way to the 6 meter. The next thing is we want to see what supports do we have in this problem. Here we have support at A, and this type of support is called fixed support. Fixed support restrict the movement in the vertical, horizontal, and rotational movements. While at B, we have a roller support. Roller support only restrict the movement in the vertical direction. So first thing, we want to identify the support reactions. So at A, we will have a reaction force, and at B, we will have another vertical reaction force. Now, since we are not moving in the horizontal, so we don't need to put the AX. And we have a moment at A in here. Next, we will take the sum of the moment at A, and counterclockwise is positive. So once we say taking the moment at A, it's always a good practice to draw a center of a circle at the axis of rotation, just like that. And we can think of this as a wheel. So now what we want to do is we want to take the moment. Okay, so let's take a moment at B sub y. The moment is the load, the force, times the perpendicular distance. The perpendicular distance is 6 meters. So when we move B sub y at the edge of the wheel, it will cause the wheel to rotate counterclockwise. So that will be a positive moment. And here we have 12 kilonewton times meter. It's being rotated clockwise, so that would be negative moment. So here B sub y times 6 minus 12. So here we want to solve for B sub y. So 12 will go to the other side of the equation, will be 12. Minus 12, it will be other side 12, and 6, it will be 12 divided by 6, it will give you 2. So this will be 2 kilonewton. Next, we will sum of the forces in the y direction, and up is positive. So A sub y plus 2 kilonewton makes sense. A sub y is positive up, and 2 kilonewton is positive up. So now what we want to do is we want to solve for A sub y, and 2 will move to the other side of the equation, will be negative 2. What does negative mean? Negative mean that our initial assumption was wrong. So right here, we need to erase this arrow going upward and change the direction going downward. And the value here is 2 kilonewton. Now, what we want to do is we want to make a cut so we can find the internal shear force and the internal net moment that is caused by the external loads, like the 2 kilonewton at A and the 2 kilonewton at B, and the external moment at B, which is the 12 kilonewton times meter. So here what we will do is we will make a cut at an arbitrary distance x, and this arbitrary cut will start from the left hand side from 0 meter all the way to an x amount of meter. At 0 meter, at support A, we will have a downward force of 2 kilonewton, and here we will assume a downward shear force internal shear force. And here we will assume counterclockwise positive moment at that cut. These are both internal. So what we can do now is we want to sum the forces in the y direction. And here 2 will be negative 2 kilonewton, and the internal shear force will be also negative shear force. And that's what we have in here. So now we need to solve for the shear force as a function of x. And we will move shear force to the other side of the equation, which will give us shear force equal to negative 2. So now we can take the moment at x, where counterclockwise is positive, equal to 0. Now, instead of taking this step, you can just integrate your shear function. So if we integrated -2, it will give us -2x. But let's move on and do the summing the moment at x. So right here, so we said we are summing the moment at x. So the first thing I do is I draw a center of the circle at the axis of rotation where we are taking the moment. And the first thing, we know that moment is force times the perpendicular distance. So here we will have 2 that will move to the right here. And this 2 kilonewton will cause the wheel to go counterclockwise, which will be a positive moment. So it will be 2 times x plus mx. And that's what we're going to have in here. And here we want to find the mx. So it will be mx equal to minus 2x. Now we can draw the shear and moment diagram. So right here, first thing first, at A we have a downward force of 2 kilonewton, and now the shear force, the internal shear force as a function of x is equal to -2. So at 0 is -2, and at 6 is also -2. So now we can draw this line right here. And this line represents this function. And at B, we have a 2 kilonewton going upward. So now we close the shear diagram. Next, let's do the moment diagram. And so the function that we have for the internal net moment is -2x. At 0, it will be 0. At 6, it will be -12. So here we can draw this line, which is represented by this function. And at B, we have 2 kilonewton, 12 kilonewton, which will close the bending moment, the moment diagram. Thank you very much. Have a good day.